Hi everyone. In today's section, we're going to see proving quadrilaterals are parallelograms. In the previous section 6.2, we studied the properties of parallelograms. And if you remember, we know that a quadrilateral is a parallelogram if the opposite sides of these are congruent. That's one of the properties. Actually, the definition of parallelogram for one of the ideas. Then also we have that in a parallelogram, both pairs of opposite sides are parallel. So that's another property of parallelograms. Also, opposite sides are congruent. Another property of parallelograms is that the opposite angles are also congruent. Another one is that the consecutive angles in a parallelogram are supplementary. That means that they add up to 180 degrees. And another property of parallelograms is that the diagonals bisect each other. Now, what is the connection between this section and the previous one? In this section, guys, what we're going to prove is that a quadrilateral is a parallelogram. So, in the previous section, we took for granted that a figure was a parallelogram. And now that we know that there is a parallelogram, we start making the list of the properties. But in this case, in this section, we're going to prove that a quadrilateral is a parallelogram. So how can I prove that a quadrilateral is a parallelogram? So in here, we have one way of proving it. And one way is to guarantee that the quadrilateral has both pairs of opposite sides that are parallel. So this is the definition of parallelogram. A parallelogram is a quadrilateral that has both pairs of opposite sides that are parallel. So that would be one way of proving it. You need to put that a quadrilateral is a parallelogram. Both pairs of opposite sides must be congruent. What is another way of proving that a quadrilateral is a parallelogram? Okay, another way it is to prove that both pairs of opposite sides are parallel. If we can prove that both pairs of opposite sides are parallel, we can guarantee that this quadrilateral is a parallelogram. Also, if both pairs of opposite angles are congruent, guarantee that the quadrilateral that we have, it is a parallelogram. Another way, if both pairs of opposite sides are congruent, guarantee that the quadrilateral that we have, it is a parallelogram. If in the quadrilateral that we have, the consecutive angles are supplementary, guarantee that the quadrilateral is also a parallelogram. Another way, if it happens that the quadrilateral that we have, in the diagonals bisect each other, guarantee that this quadrilateral is a parallelogram. And another one, if one pair of opposite sides are congruent and parallel, guarantee that the quadrilateral that we have, it is a parallelogram. Now, having this on mind, you should have this I hope that you can copy this in your notebook, that you have your notebook, that you can copy this, or that you can have this in hand, because these are the ways that we're going to prove that the quadrilateral is a parallelogram. How many ways do we have in here? We have one that is the definition, and 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7 ways, guys, to prove that a quadrilateral is a parallelogram. So let's see how this works. Let's make an example. In example 1, I have this figure that I'm giving to you, and the question is this parallelogram is this quadrilateral parallelogram? So think a little bit, and let's see what we have in here. I can, if you want to make some labeling in the figure, just to have the figure without any names. This is A, this is B, this is C, this is D, and I can see in this figure that the segment AB, it is parallel to the segment CD, and also I can see that the segment AC, it is parallel to the segment BD. And I think that you're thinking the same that I'm thinking, that this, yes, this quadrilateral is a parallelogram because I have two pairs of opposite sides that are congruent. So this quadrilateral, ABCD, let me write that over here. This quadrilateral ABDC, let me erase a little bit over here. ABDC is a parallelogram. And what I used in here was that I proved actually that I have two pairs of opposite sides that are congruent. Therefore, ABCD is a parallelogram. Let's see the second example. But before, let me erase this information that I have over here. And now we are ready for the second one. Is the figure that I have in here a parallelogram? See what is given. If you want, we can make some labeling in here. I have, let me call this parallelogram. Let me name it. Let me say that this is A, E, G, and D. And I notice that the segments in red are diagonals. I see that the diagonals intersect and they meet at this point that I can call M. And I notice that because of the marking that the diagonals bisect each other. So if they bisect each other, it means that the length of the segment AM is the same as the length of the segment MD, and the length of the segment GM is the same as MD. So is this parallelogram, quadrilateral parallelogram? I think that your answer is yes, because the diagonals bisect each other. Let's make another example. But before making the next example, let me clear this out. And yes, now we're ready. Example 3. The figure that we have over here, is that a parallelogram? Think a little bit. What you're thinking of this, let me make some writing in here. Let me, as I did before, let me label this vertices. Let me call this E. Let me call this D, F, and G. And let me see. I have the measure of the angle E, that is 70 degrees. I have the measure of the angle F, that is 170 degrees. And I notice that the angle E and angle F, if I add the measure of both of them, they add up to 180 degrees. I notice that if I add the measure of the angle E with the measure of the angle D, 70 plus 110, they add up to 180 degrees. And here is missing the G, but I think that it's easy to find. There are several ways of finding G, but if you know that the sum of the angles in a quadrilateral is 360, and from 360 you subtract the sum of the three angles that is given, that it would be 110 plus 110, it would be 220, 220 plus 70 would be 290, and since the sum of the four angles, it should be 360, we subtract 360 minus 290, and the answer for the G angle would be 70 degrees. And actually here there will be like two ways of proving it, but the way that it was at the beginning, since at the beginning we can notice that angle E and angle F, for example, are supplementary. E and D are also supplementary. They add up to 180. F and G are supplementary, and D and G are also supplementary. So the answer is this one, guys. The consecutive angles are supplementary. So yes, this quadrilateral EDGF, it is a parallelogram because I proved that the consecutive angles are supplementary. Let's do one more. But before, let me clear this out. Okay, and let's do number 4. And I have this figure. Is this parallelogram? Is this figure? Is this quadrilateral a parallelogram? So let me make some labeling. It's really good to name the vertices of this figure. Let me call this G, this E, This is O and this M. And let me see what I have in here. I have that the segment GE, it is parallel to the segment MO. How do I know it? Because of these markings over here. Those arrowheads are telling me that these two sides are parallel. And see that I don't know they are congruent, that is only parallel. And also from the figure, I can see that the segment GM, it is congruent because of this marking with the segment OE. So I have that, this is what I have, that I have one pair of sides that are parallel and another pair of sides that are congruent. Is this enough? Is this completely enough to prove that this figure, this quadrilateral GEOM is a parallelogram? Think a little bit. If you remember the properties or the ways that we can prove that a quadrilateral is a parallelogram, they don't mention that. So in here, the answer is not necessarily. Both sets of opposite sides must be parallel. And in here I have only one pair of sides that are parallel, and the other one are congruent. So combining this information is not enough to prove that this figure, this quadrilateral, is a parallelogram. So not necessarily, it could be. But in general, you may say that this, no, is not a parallelogram. So let's see, let me erase before. Let me erase this information. Here we go. Let's go with the next example. And in these exercises, guys, I'm gonna solve it with you. But in here, please start thinking, if you're looking at this video, if we have enough information for proving that this quadrilateral, in this case quadrilateral, I can call it ADCB, it is a parallelogram. And let's use the information that they give us. And let me make some marking. I have AE, it is congruent with the segment EC. And also that the segment DE, it is congruent with the segment EB. So as you can see, I have these segments AC and DB that are the diagonals, and I can clearly see the diagonals bisect each other, and the point of intersection, the midpoint for both, is the point E. So can we say that this quadrilateral ABCD or ADCB or DCBA, it doesn't matter how you name it by using the four letters in consecutive order, is this a parallelogram? I hope that your answer is yes. And the answer is yes, because the diagonals bisect. And let's see another exercise. In this one, they give us this quadrilateral. If the angle ADC is congruent with the angle ABC, is this a parallelogram? So if it is, we're going to justify the answer that is yes, or in case it's not, we will say why it is not. So let us see. In this case, I have, let me make some marking. I have that this figure over here has an angle ADC. This angle ADC, this one, is congruent with the angle ABC. Sorry, let me do this again. Okay, this angle ADC, yeah, it's marked already. Let me make a marking on the angle ABC. It's this one over here. And I think that you identify these two angles that they give us in here are these kind of angles, opposite angles. But it's only one pair given. So these two angles, ADC and ABC, are opposite angles, and they are congruent. Perfect, it works really nice. But there is one way of proving that a quadrilateral is a parallelogram. It is if two pairs of opposite angles are congruent. And in here, they only give us one pair of opposite angles. So can I conclude that this quadrilateral is a parallelogram? Think a little bit. I think that the answer that it comes to your mind is that it's no, because if we're gonna use, if we need to prove that this quadrilateral is a parallelogram, we need to have two pair of congruent opposite angles. And in this case, I have only one pair. So it is not necessarily, this figure is not necessarily a parallelogram. So in general, we say, no, it's not a parallelogram. Let me erase again what I wrote. And let's make another one. And I have this figure. And in this figure, AB, segment AB is congruent with the segment CD, and the segment AD is congruent with the segment BC. And again, the question for us is this a parallelogram? And we need to justify the answer. So let me see. Let me once again use my pen to make some marking on this. And let me see, they give us that AB, segment AB is congruent with the segment SCD. I already indicate that. Also, the segment AD, it is congruent with the segment BC. This is what I have. And if you notice, AB is segment, these two segments, AB and segment DC are opposite. And also, let me switch color, you can see that clear. Also, I notice that the segment AD and the segment BC are opposite. So I have two pairs of opposite sides in this quadrilateral, and I think that it comes to your mind the property that says, yes, this is gonna be, I just proved that this quadrilateral is a parallelogram because the opposite sides are congruent. Perfect, let's do one more. And let me, I always forget this, guys. Let me clean this out. And I have this figure, the next one. And in this case, I have that the segment AB, it is parallel to the segment CD, and that the segment AD is parallel to the segment BC. So again, is this quadrilateral parallelogram? So let's see what I have, and let me use some marking of the figure so we can see that clearly. I have given that the segment AB, it is parallel. This is the way that we indicate the two segments are parallel. So this is parallel to the segment, AB is parallel to the segment DC. And also the segment AD, so let me use a double arrowhead. It is parallel to the segment BC. So are they, I mean, is this parallelogram AB, is this a quadrilateral parallelogram? I think that it comes to your mind. I see I have two pairs of opposite sides that are parallel. There is a property that says this, a property to prove that a quadrilateral is a parallelogram, and the answer is yes, because this is a parallelogram because the opposite sides are parallel. Perfect. Let's do one more. Let me clean this out. And in the next one, we're going to use a little bit algebra. And here it says, what values for X and Y guarantee that the quadrilateral is a parallelogram? And we need to justify the answer. Okay, I notice in here, let me use my magic pen. I notice that this side that is labeled with 4x and this that is labeled with 20 are opposite sides. So since they are opposite sides, I know there is a property that states that, I mean, how can I prove? Let me restate this. I need to guarantee that this quadrilateral is a parallelogram. So if it is going to be a parallelogram, opposite sides must be congruent. So this is telling me that what I need to do in here, I'm going to write that in here. Opposite sides must be congruent. So what I need to guarantee is, out of this, two things: that this side that is represented by 4x measures the same as the side that is represented by 20. So 4x must be equals to 20. So this is one of the things that I need to prove. But also, I need to prove that the other pair of sides, let me use another color, this that is labeled 5y and this that is labeled 40, that measures 40, these two sides, if this quadrilateral pretends to be a parallelogram, they also must be congruent. In other words, they must measure the same. So how can I guarantee that they measure the same? I need to write an equation with 5y and 40. So 5y equals 40. Let me solve both equations. In one hand, on one side I have for x equals to 20. I divide both sides by 4. This is gone. X will be equals to 20 divided by 5. So the value of the x is 5. And on the other side, 5y equals 40. Same procedure, I divide by 5. And this is gone. And y must be equals to 40 divided by 5 is equals to 8. So the values that guarantee that this quadrilateral is a parallelogram are x equals 5 and y equals 8. And we just prove that this figure, it is a quadrilateral if the values of the x and y are 5 and 8. So opposite sides. Okay, let's do one more exercise. I have this figure and I need to find for what values of x and y this figure, it would be a parallelogram. Okay, let's see what is given. I notice that one of the angles measures 64, the 127, and the other side I have one angle that measures 6.8 3x plus 6, and the other one it is 8y degrees, so it's 8y. That would be, we need to find the value of the x and the value of the y. So here, guys, this, I think that it comes to your mind, something that we learned from previous sections, and is the following. Let me make some marking here. And I notice that if I extend this a little bit, and let me use another color here to extend this. If I extend this one, let me use another color because it's like a, let me use green. If I extend this side and this one, these two sides are intersected by the line in blue, so this would be a transversal, the one in blue. So if you remember, this is a transversal. If you remember from what we learned previously, if we can prove that alternate these angles are alternate interior. If we have two lines carved out transversal, then these two angles are interior, and actually they are called alternate interior angles. So in here, what we can do, it is, maybe it is not on the list of the properties that we mentioned, but we know the following. I repeat it, sorry that I'm going to mention this again. If we have two lines that are carved out transversal, these angles that I'm pointing out again are alternate interior angles. So if two alternate interior angles are congruent, then these two lines in green, they will be parallel. So this is one way also to prove that this is a quadrilateral. So we're going to use this idea. Alternate interior angles must be congruent. So if they are going to be congruent, that means that I'm going to write two equations like I did before. I'm going to write the following equations. 60, let me begin with the one that I'm marking here. 3x plus 6 must be equals 27. These angles are alternate interior angle. But also, guys, these two angles that I'm going to mark at this moment are or can be called alternate interior angles. So those also are alternate interior angles for these lines or segments that I'm going to mark at this moment. This and this. So if I have these lines, in the ones or segments in the ones in yellow, and with the same line that is in blue, that is the transversal, the angles that I mark in here in yellow with a double arc, if they are congruent, it is guaranteed that these yellow lines or segments are going to be also congruent. They're going to be also parallel, so parallel. So we will be proving at the end that we have two pairs of parallel lines, opposite sides that are parallel. So what we need in here, guys, is the same idea that I did in the first one. I need to prove that these angles in yellow, 64 and AY, are also congruent. So alternating two angles must be congruent. So I said AY equals 64. Now, let us solve both equations. Let me begin with the first one. 3x must be equals 3x must be equals to 27 minus 6. 3x equals 27 minus 6 becomes will be 21. Then I need to divide both sides by 3. This is gone, the 3, and the value of the x will be equals 7. And in the second equation, I can divide both sides by 8. This is gone, the 8, and the y becomes equals 8. So the values that guarantee that this quadrilateral, it is a parallelogram, is x equals 7 and y equals 8. And the idea that I'm using here is that alternating two angles are congruent. Let me erase this so we can do one more. The next exercise, for what values of x and y is guaranteed that this figure that I have here, this quadrilateral, is a parallelogram. So let me see. Let me analyze the situation. I think that you're doing the same. And I noticed that the angle, or the angles that are labeled 5x plus y and 4x minus y are consecutive angles. And if I need to prove that this quadrilateral is a parallelogram, it would be enough to prove that these two consecutive angles are supplementary. So that's what I'm going to prove at this moment. So consecutive angles are supplementary. So if they're supplementary, it means that they add up to 180 degrees. So let me write in here, guys. And what I'm going to write in here is that the sum of 5x plus y and 4x minus y is going to be equals to 180 degrees. And we have, let me see, this equation. And okay, with this equation, I notice that it has two variables. And if I need to solve it, it's kind of impossible. If I have only one equation with two variables, it's kind of impossible to solve it. But I'm gonna do the following. I have this equation, nothing is wrong. Let me simplify this. 5x plus 4. Actually, guys, yeah, it's no problem with this. I was thinking of write a system of linear equations that you know how to do that, but it is not needed. So because actually I noticed at the end that y and negative y disappear, so my equation, it becomes, as I need it, an equation with only one variable, and 5x plus 4x would be 9x equals 180. And then I divide both sides by 9, and the value of the x becomes 180 divided by 9, it will be 20. So this is the value of the x that I need. At the beginning, I was thinking to write two equations, two linear equations, so a system of linear equations. But when I wrote it and I analyzed what I have in this equation, 5x plus y plus 4x minus y equals 180, I noticed that the y cancels. So that leads us to an equation with only one variable. And I have that the value of the x, it is 20. Now, the question is, how can I find the value of the y? I hope that you're thinking for a moment, how can I find the value of the y? What can I do to prove or to find the value of the y? What can I do? I'm just making a silence. I'm not giving exactly what I should do, so you can think a little bit what it should be done. Okay, if you think a little bit, what can it be done? It actually is more than one way. I can, for example, one way, guys, maybe you think of another one. It is to see what it would be the measure of this angle. And I think that you're thinking, okay, this angle that I have a question mark, along with the one that is 125 degrees, are consecutive angles. So these two angles are up to 180 degrees. Therefore, the measure of the angle that it has my question mark in here, it will be 180 minus 125. And 180 minus 125, it would be 180 minus 120, it would be 50, 125, it would be 55 degrees. So let me write this value over here, 55. This angle over here measures 55 degrees. So, having this clear, I can keep on using consecutive angles as supplementary, or I can use another idea. I know that opposite angles must be congruent if I'm proving that a quadrilateral is a parallelogram. But to keep this idea of consecutive angles as supplementary, I'm gonna propose the following equation. Let me call the first one that I did 1, and the one that I'm gonna solve at this moment 2. I'm gonna propose this equation: 5x plus y equals, plus, I need to add also, 5x plus y plus 55, it must be equals 180 degrees. Why? Because these two angles, the ones that measure 5y plus y and 55, are consecutive angles, so therefore they must add up to 180 degrees. Okay, let me simplify this. Maybe you notice that I have two equations. I have an equation with two variables, but don't worry, because I know the value of the x, so I replace the value of the x, and I will have an equation with only one variable, the y variable. So let me do something. Let me stop. If you want, let me replace the value of the x. I know that the value of the x, it is, because I found it in the first equation, I know that is 20, so replace by 20, and let me continue. 5, the value of the x is 20, so I replace it. 5 times 20 plus y plus 55 equals 180. 5 times 20 will be 100 plus y plus 55 equals 180. Let me, I don't have too much space. Let me simplify something here. 100 plus 55, it will be 155. So this becomes y plus 155. Y plus 155 equals 180. Let me leave alone the y. Y will be equals 180 minus 155. When it's the y plus, I have an addition in here. When I get rid of that addition, on the other side is a subtraction. So 180 minus 155, it will be 25. So we just found the value of the y. So at the end, guys, we have the two values. The value of the x is 20, and the value of the y equals 25. These two values guarantee that this quadrilateral that I have in here, it is a parallelogram.